in today's video, you'll be learning about the arithmetic of imaginary numbers. Say, for example, if we had 6i plus 4 minus 5i plus 3. Well, 6i minus 5i, what would that be? You might be getting confused about the imaginary number I. Well, let's just say you had the variables a instead of I, okay? Minus 5a. Well, this is going to be equal to a, and we kind of involve the same method of subtraction in this problem here, right? 6i minus 5i would just be I. 4 plus 3 would just be 7, and then that's your answer for the simplification process. Now, we'll get to a bit harder example. So 3i plus 16 minus 17i plus 6. If you want, you can do this by yourself, so yeah, pause the video. Okay, now that you've given it an attempt, we first, distribute the negative sign, then we distribute to negative 17, we distribute to 17i, and then to 6, so we get negative 6, and then 3i, minus 17i is just negative 14i, and then 16 minus 6 is just 10, and that's your answer. Okay. And now we'll move on to multiplication and division now. And at the end of this video, I'll have fewer problems that will work out together. So don't worry about if I'm rushing. I'll put out more problems that I'll do, and then for you to gain knowledge about. For multiplication, it's actually very similar to quadratic multiplication, and I'll show you why. So as you can see here, this is one way of multiplying imaginary numbers, and the other way, I'll just solve this one first, and the other way is either 4i, maybe 4i times 3, or maybe I times 5i, okay? Oh, sorry. I'm going to put a multiplication sign there. I times 5i, okay? So for the second one, treat I as a normal variable in this case, So 4a times 3. And that'll give you 12a. So again, here you kind of involve the same method. So you get 12i. And we can do this since 3 isn't associated with I. Okay? Here, it's a different story. Since we have two kind of terms associated with I, this is going to be equal to 5i squared. Okay, and 5i squared is just negative 1. So this is then going to be equal to negative 5. Okay. Now here, we have an example we have up top. It's a different story. Here, as I said earlier, we use a quadratic method called foiling. Now here, how we do that is 3i times I, okay? And then 3i, since we did here to the inner, now if we go to the outer, 3i times 3 plus 3i times 3. And then now 5 times I plus 5 times I plus 15, 5 times 3. So it's very similar to quadratic multiplication in a way. Now 3i times I, just negative 3. 3i times 3, just 9i. Then we do plus 5i plus 15. 5i plus 9i is just 14i. 15 minus 3 is just 12. And then that's your answer. So now for division, believe it or not, this is actually a division problem, and it's because, right, you might be thinking, first of all, yeah, you might be getting why it is a division problem because there's a division symbol, but two is you might be thinking it's already, how's it not already simplified? Because, like, for one, the first time I saw this, I was like, how come you can simplify this even more? It already looks simplified. However, there's actually a way to simplify this furthermore, and this is through the conjugate. Okay, the conjugate, and basically, what the conjugate does is that you basically look at the denominator, okay, and the denominator here is I plus 3. Now, you would multiply it by I minus 3, okay? So you kind of flip the symbol. So I minus 3, okay? And whatever you do to the denominator, you have to do to the numerator. So it would be I minus 3 in the numerator too. So now we kind of just incorporate multiplication here. So that's why division can be a bit more tedious than multiplication and the rest of the arithmetic rules. So 3i times I, times negative 3, and 5 times I, so 5i, and 5 times negative 3, so negative 15. Okay. I times I, you get I squared. I times negative 3, negative 3i. 3 times I, so plus 3i. 3 times negative 3, so that's just, oh yeah, negative 9. Okay. Here, right, I'll just write a bit more simple way. So we have I times I is just negative 1, so we get negative 3 minus negative 9i plus 5i, okay, minus 15. The negative 3i and plus 3i, they cancel out, so then we're left with I squared. Okay, I squared is just negative 1, so then negative 1 minus 9, minus 9 is just 10, negative 10. So the denominator is just negative 10. And then we're almost done. So 9i, negative 9i plus 5i is just negative 4i. Negative 3 minus negative 15 is just negative 18. Okay, and then over negative 10. And this can actually be simplified, right? If you multiply each, if you want, you can do this. You can multiply the denominator and numerator. I'll just write this up top here. Over here. You can write this as, right, multiply the denominator and the numerator by negative 1. And then it will become 4i plus 18 over 10. And that would be our answer. Okay. You can simplify this to, if you wanted to. Actually, we'll do that right now. You could also do this, right? You could also simplify this to 2i plus 9 over 5, right? Because if you divide the numerator and denominator by 2. So yeah, this is a better answer. Okay, so now I'll give you a few problems to do by yourself, and then I'll solve them. Okay, so this is the first problem. The second problem, and the final problem for the review is this one. Okay. Okay. So pause the video and try to do this by yourself. Okay, so for the first one, as you can see here, the conjugate of I plus 4 is just I minus 4. You just kind of multiply by the reverse sign. Okay, and then, right, multiply the top by I minus 4 too. So when we do this, we get 4i times I is just negative 4. 4i times negative 4 is just negative 16i. 6i times I is just, well, 6i. 6 times negative 4 is just negative 24 over I times I, negative 1. I times 4, so I times 4 is just negative 4, 4i, and then 4i, 4 times I is just 4i, so then those terms will cancel out. And then 4 times, what is that? Negative 4 is just negative 16. So we just get negative 16 here. And let me just put parentheses here to make it more clear and more mathematically organized. Okay, so if you're confused by the lack of parentheses, I put them there. Okay, so then this comes out to be, right, negative 28, negative 4 minus negative 24 is negative 28. And then negative 16i plus 6 is just negative 10i over negative 1 minus 16 is just negative 17. Then this is equal to 28 plus 10i over 17. And that's your answer. So yes, as you can see here, division is kind of the most tedious, but if you can just identify what the conjugate is, it's not really too tedious after that, as it's just a lot of algebra and rules to follow. Yeah, I would say for division, most important is finding out what the conjugate is. Finding out what the conjugate is. Okay. So for the second one, I times I is just negative 1. I times negative 5. I times negative 5 is just negative 5i. 3 times I is just plus 3i. 3 times negative 5 is just negative 15. So then our answer is just, well, negative I plus 3i is just negative 2i. Negative 1 minus, negative 1 minus 15 is just negative 16. That's our answer. Now for our last one, we have 3i plus 3i. Again, treat I as a variable in this case. So we get 6i. And then negative 5 plus 6, or 6 minus 5, is just 1. So we get 6i plus 1. Yep, again, 6i plus 1. Alright, so that was the arithmetic of imaginary numbers, and I'll see you in the next video.